Hello everyone, I'm Paul and today we're solving problem 1792, maximum average pass ratio. I find this one interesting, so next I will show you my thought process, intuition, approach, and efficient solution. We are given an array classes where each class has two elements, the number of students who pass the class and the total number of students for that class. So if we want to get the pass ratio for this class, we just do pass divided by total. And if we want to get the pass ratio, the average pass ratio for all classes, we do this plus every pass ratio divided by the number of classes. We are also given an integer extra students. These are students that are guaranteed to pass the exam of any class they are assigned to. And our job is down here. We need to return the maximum possible average pass ratio after assigning the extra students to any class or classes. So let's say we have this class. We have 2 students in total and pass is 1. Now the current pass ratio for this class is 1 divided by 2. This is 0.5. Now, if we add one student here, we need to do 1 plus 1 divided by 2 plus 1. And this is how we get the new pass ratio. And 2 divided by 3 is 0.66. Now, what is the difference among these two states? Well, we can do 0.66 minus 0.5, and this is 0.166. So this is the contribution for adding one student to this class. And this is the key for this problem. We can take this contribution and build a max heap based on this contribution, and each time we add a new student to the top of our max heap. Let's see how this works. Let's say we have this input. The first step is to build a heap. So we can iterate every class. We start from here and we do the same as before. We take the current pass ratio, which is 1 divided by 2, and the new pass ratio, which is 1 plus 1 divided by 2 plus 1, and the difference among these two in this case is 0.166. So we can store a tuple in our max heap with this value, the current pass number, which is 1, and the current total number, which is 2. And we are storing this tuple in our max heap. Remember, when we are using the max heap, the weight is given by the first element in the tuple, so we need to put this in the first position. Now we are here and we do exactly the same. The new pass ratio is 3 plus 1 divided by 5 plus 1, and the current pass ratio is 3 divided by 5. So the difference among these two is 0.066. So this is the contribution for adding a new student to this class. The pass number for this class is 3 and the total number is 5. So here we add 3 and 5. Now we are here and we do exactly the same. 2 plus 1 divided by 2 plus 1 new student is the new state, and the current state is 2 divided by 2, and this minus this is 0. So this is the contribution for adding a new student here. So we add to our heap 0 and these two numbers, 2 and 2. The second step here is to add extra students. First, we take the top of the heap, which is this one, because this is the greatest number among this, this, and this. So now we are adding a new student to this class. this number is 2 now, this number is 3, and we need to calculate this again. The current state is 2 divided by 3. And the contribution, if we decide to add another student to this class, would be 2 plus 1 divided by 3 plus 1, and this is minus the current state. The result for this is 0.83. So we replace this with this number, 0.83. Now we need to add one more student, so we do exactly the same. We check which is the top of our max heap, and it's this one again, because this is the greatest weight among this, this, and this. So this number is now 3, this number is now 4, the current state is 3 divided by 4, the new state is 3 plus 1 divided by 4 plus 1, and the contribution is this minus the current state. The result for this is 0.05. So we replace this with 0.05. Now this is 0, and we can get the average pass ratio for all classes. So we take the pass ratio for every class, which is 3 divided by 4 plus 3 divided by 5 plus 2 divided by 2. This is 2.35, and this divided by 3 classes is 0.783, so we return this value. This is the maximum possible average pass ratio among all classes after adding all extra students. So this is it for the approach. Now let's go with the code, and hopefully you will get the idea. First, we need to build a function to get the contribution for adding a new student to any class. We will call this con, and this takes 2 arguments, pass and total. So the current pass ratio is pass divided by total, and the new pass ratio is pass plus 1 divided by total plus 1. And here we can just return new pass ratio minus current. Now our heap is initially empty, and here we can iterate classes. So for pt in classes, and we add to our heap. Here we use append because right now we have a list. Then we will transform this into a heap. So we use append, and we want to add a tuple with 3 values. The first one is the contribution for the current, pass, and total. The second one is pass. The third one is total. And given that this is a max heap, here we want to use a minus. This is what we do with max heaps in Python. And after doing this, we can transform this list into a heap like this. Heap q, heap p5, heap. This requires big O of n time complexity. That's why we are doing this way. Here you could use heap push instead for every element, but that requires big O of n log n time complexity. So this approach is overall more efficient. Now for every value in extra students, sorry, this is range extra students, we have 3 values for every element in our heap. We want to pop the first one, so heap q, heap pop, and this gives 3 values: await, pass, and total. And now we can add to our heap, heap q, heap push, heap. We add a new tuple with the current class and the new student. So here we use contribution for p plus 1, t plus 1, p plus 1, t plus 1. And here we need to add minus because we are working with a max heap. So this is basically the same we did before. And finally, after adding every extra student, we can get the result. This is initially 0 and for underscore pt in heap result plus equal p divided by t, and finally we return result divided by the length of classes. So this is the average pass ratio for every class after adding extra students. So this is it for the code. Now let's submit this and see if it works. Here I'm missing letter H, so let's fix this and try again. As you can see, this works and it's very efficient. Time complexity here will be big O of n for this part. For this part will be big O of m log n, where m is the number of extra students and we do times log n for heap operations, and for this part it's big O of n. So it's overall big O of n plus m log n, and space complexity will be big O of n. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.